All right, well, thanks for being here. We're going to talk about a dozen cool things we can do with JVM languages. I'm going to touch on things we can do in Java 8 to Groovy to Scala to a bit about Kotlin as well. So why talk about these popular JVM languages? One of the things that I've really enjoyed doing is being a polyglot programmer is using the tools that make sense for the task at hand. Well, that's one of the beautiful things about the ecosystem we live on. We are not forced to really use a particular language. In a fairly large application, we can mix and match things that might be a better tool for a particular job. In a way, I would argue that I look at languages like vehicles. There are times I would like to ride my bicycle. There are times when I have to take a car or take an airplane to go to a different city. So the point really is, in a given day, it's quite likely that we use multiple vehicles, so I would consider languages as well. Well, I want to talk about a dozen cool things I've found really nice in these languages. So let's start with something we can do is to access a file. Well, I want to read a file. How do I read the content of a file? Well, we know how hard it really is to do this in Java, for example, with all the things that you have to deal with exceptions and also to read the content and then loop through it. Why bother doing all of that work when we can do this much more elegantly? So let's start a little bit with a little example. Let's say I just want to read the file that is containing this code itself. To have the screen would be really nice, wouldn't it be? So let's see if that can be done. So who is going to do that for us? You mean you cannot just read the code from my words? So could we switch over to the screen here, please? Hello? Maybe they're out at lunch. All right. Okay. No. There we go. Awesome. This is amazing when technology works, right? All right. So what we're going to do here is we want to talk about, that's what I wanted to show you in the first place. I had the assumption you were looking at it. Okay, so what we're going to do here is to read some file. So why don't we read the file itself, that one that we have the code in? That would be really nice to have, isn't it? So for that purpose, what I want to do here is simply go back here and say, let's start with a little print over here. And what do I want to print, after all, in this code? Well, I want to print right here, new file, and in this case, we will go ahead and ask for the sample.groovy, which is the file that contains this particular text, and ask it to bring the text out. So that's as simple as that. Didn't take a whole lot of effort. This is Groovy's file object, and then we are using the text method that the Groovy Developer Kit GDK has added to it, and we are able to just get the content of the file. So that becomes really easy to get the file's content, as you can see, within Groovy. Well, similarly here, in Scala, we can do that as well. So I'm going to go ahead and print it, but in this case, I'm going to say scala.io.source, and then I'm going to say from file, and the file I'm interested in, this file is a sample.scala. It could have been a .groovy as well, but in this case, I'm going to use a make string, which is really concatenating the string together. That's what this is really doing. And that's a one-liner really here to get the content of the same file from within Scala as well. As you can see, that's not really that difficult. So that's an example of how we can read a file really nicely. But one of the other things I like to do quite often is to be able to get the contents running in a process. I want to start a process. How do I do it? Well, clearly Java provides the foundation for it. We are definitely using the JDK, no doubt about it, but we don't have to struggle through so much of effort as well if we want to simply start a process. So let's say for a minute, I just want to call a git help, and that's all I want to do is just run the git program and ask for help from it. Well, I can create a process object, I can do a lot of stuff, but why bother doing so much effort? We'll just say print line right here, and that's a string on which we can call an execute method. Again, that's a method from the GDK, and then I can call the text on it and then get the content out of it, and that right there is the output from the git help. And of course, if you really want to tie into the standard input, you can do that, standard output, you can do all of that very easily, and that's the beautiful execute method method added to the string, and as a result, we can really benefit from that. This also points to something else. Our ability to take classes and add our own methods to it is something that can be really powerful for doing domain-specific actions on it. We'll see how we can do that towards the end of this presentation as well. So having said that, one of the things I really like about Lambda expressions is some really old design patterns that were popular in languages like in Smalltalk and other languages is now available for us to use in languages like Java. So to understand this, let's take a really quick example and play with it. Let's say we have a class called resource right now. And what does this resource contain? It contains a constructor. We will say this particular constructor resource, all it's going to do is simply output, let's say, created. Well, that's great. I want to write another method. In this case, I'll call it resource op1. And all this is going to do is simply output op1, and it's going to return the current object. Let's also do one more thing. We have an op2, and all that's going to do is simply return that this after printing op2. But finally, I write a method which is the finalize method, which we know is a bad idea with all the experience we have so far, but I'm going to say clean up. Well, the reason I'm providing a cleanup here is I have an external resource, maybe a database I'm talking to, maybe an external file, maybe a resource out on the web, whatever that could be. So what I really want to do is to use this resource. So I'm going to say resource over here. Resource is equal to, let's say, new resource. We created that. And then I'm going to say resource.op1. And then I'm going to also call resource.op2. But unfortunately, though, when I run this code, notice it did print those, but it never called the cleanup. Why not? Because the cleanup is going to happen when the garbage collector decides to collect the garbage. But since I have a lot of memory, the garbage collector decided not to run. In fact, to add insult to injury, there are methods like system.gc. Another name for this is called bad idea, right? Because this actually is not going to really run. Why not? Because when I do this code, the only thing that really got collected here is my ego to say that it's going to run, because it completely ignores me. This is kind of like the garbage collector in my neighborhood. Just because I call them doesn't mean they do anything for me. And the only thing is the frustration that I just actually called them. So what do we do about it? Well, Java, of course, has ARM, which is the automatic resource manager. So let's talk about ARM really quickly. What does ARM do? So ARM stands for automatic, resource management, and this is also known as try with resources. So what does this really provide for us? This provides a nice way for us to garbage collect objects. So what I could do is call this as a close method rather than calling it as finalize. And I can say implements right here. And this is going to be auto-closable right here. And then, of course, once I say this is auto-closable, what I'm going to then do is come down to the code right here and say try. And then we are going to provide the resource right in there. Then we can move these two objects to here. But the beauty of this approach is it will call close automatically for us right in here, as you can see. Well, that's definitely an improvement, isn't it? We have a deterministic way to garbage collect the external resources when we need to. So why not just be happy about it? Well, the problem with this approach, unfortunately, is this requires us to write the try block. But what if I don't write the try block after all, and if I just call the method like this? The question is it going to collect the garbage right now? What do you think? Well, you're thinking maybe it will. That's called a hope, isn't it? Well, when you run this code, unfortunately, it's not going to really do the garbage collection. Okay, it's going to give you an error. No, it doesn't. Will it give you a warning? No, it will not give you a warning. But you know the answer already. We know this from experience. Never trust a feature which has management in its name. So as a result, you know never to do this. So the point is, how do we really get to the point where we can reliably garbage collect objects in scenarios like this? This is where I really like using some old pattern. So notice what I'm going to do here. I'm going to take the close method, make it private. Now, what did we achieve by doing the method as private? Well, there is no more private method available, a closed method available for us to use outside. Okay, big deal, that didn't affect us. Then I'm going to make the constructor private as well. Now, of course, you're going to wonder what gives. I can't create an object of this class over here. Now we're going to have a deterministic way to deal with the resource. So I go back to this class right here. I write a public static method called use, and the use method simply says resource is equal to, let's say, new resource. And then I provide a try block, and within this I say resource dot, well, actually we'll come back to that in a minute. Then I say catch over here, or even better, a finally method block. And within this I say resource dot close and close the resource. So I can write a use method where I create a resource. I can reuse this if I really wanted to, and in the try block we'll come back to that. But when we come back from the finally, whether there was an exception or not, we actually close this resource properly. Now what are we going to do within this? I'm going to say block dot accept, and I'm going to pass the resource to it. Obviously the question is, what in the world is the block? Well, the block actually is going to come from the functional interface. So we'll say function dot star, and then in this case we will go back here and say this is a consumer of resource, and then we'll say block right here. So what did this achieve for us at this moment? Well, all we did was we wrote a use method, and the use method receives a consumer as a block, and then we create an object of resource, but we pass the resource to the block of code, whatever it wants to do with it, and when it comes back, we're going to do the close operation. Well, the beauty of this solution now is we already know that we cannot create an object of resource like this, so it forces the programmer to do the right thing. So the programmer can say .use and call the use method like this. But within this, they receive an object of resource, and then they can simply say resource.op1 right here, and then they can say .op2, and then they can call these two methods right here in the code, and as a result, we have implemented a very tactful way to clean up the object resource deterministically without having to say, oops, I forgot to call the try block. This forces the programmer to really use the object you created, a class you created, in a certain way so that your resources can be cleaned up properly. So this becomes a very powerful way. This is called an execute around method pattern. The reason it's called execute around method pattern is you're executing on line number 20 some logic, business logic, but above that and below that or around it, you're performing other bookkeeping operations. So this becomes a nice way to implement policies in your code where before you enter a block of code, there is certain work you do, and when you exit the block of code, you do a certain work, and then within that constraint, you can really implement it very nicely. Languages like Scala call this as a loan pattern. And the reason they call it a loan pattern is this is as if the resource is given to you on loan, and then you borrow it, do something with it, and you politely return it, just like a rental car. Before you rent the car, they hopefully cleaned it up, and then when you return it, they check for damages. So this is really like an object on loan that you can use. That's what you're getting right here. So that's basically the execute around method pattern in Java 8. But you can do this in any language that has Lambda expressions very effectively, and the conciseness of Lambda really makes this easy for us to work with. Well, the next thing I want to talk about here is the traits. So what in the world is traits? Well, Java has interfaces, which is really nice, but let's talk about where this can be powerful to deviate a little bit and come up with a better example. Let's say we have a class called human for a minute, and the human has a name. Let's say that's a string that I'm going to provide. This is Scala code, and within this I'm going to provide a listen method, and all that the listen method is going to do really is simply says print out, and let's say in this case I am, and then we will print out the name, let's say $name, and we'll say listening. So in this case, we have a little listen method. We'll create an object Peter equals to new human, and this is the Peter object, and I'm simply going to say Peter.listen and call the listen method. Well, in this case, of course, we're just calling the listen method. That worked. But let's go a little further. Let's say we have a method called, let's call this as seek help, and say help from. And in this case, we'll say a friend, and we will specify a human right here. But after all, what's the characteristics of a friend? A good friend, after all, listens to us, isn't it? So in this case, I'm going to simply call friend.listen and just call the listen method on the friend. And I'm going to go ahead and call the Peter in here, seek help from Peter, and call that little method. And you can see that actually worked just fine. But of course, in this case, the listen is a method on human. While humans listen, well, at least some of them do, but it's really a characteristic of a friend, isn't it? So who is really a friend? A friend is somebody who will listen to you. You go meet your friend in the evening after a very long day work, and you sit down and say, you know what, this job really sucks. And what does a good friend say? The good friend says, tell me about it. What does a bad friend say? Maybe you suck, not your job. That's how you know who your friends are. But the point is, a friend always listens to you. But it turns out there is one best friend we all humans have, which is dogs, after all. Because dog always listens to you, never talks back to you in a bad way. So that's a really awesome friend. So let's bring in a dog as a friend. So what am I going to do? Say, excuse me, class animal, and an animal contains a name, after all. We'll say a val name here as well. And then the name, of course, is a string. But then I say dog, in this case, is going to override the name over here. So overrides name, which is a string. And I'm going to go ahead and pass that over here, extends animal, and of course we'll pass the name over here to the dog. So all we did was we created a dog class. But then I want to come in here and say buddy is equal to new dog, and we'll create a buddy dog. And now I say seek help from buddy, and you know that's not going to work. Why not? Because buddy is not a human, buddy is a dog. Now don't try to come up with this fantastic idea of inheriting a dog from a human. Dogs don't like it. So what is the solution we normally come up with in the case of Java? Well, what we normally do in Java is we create an interface called friend. Well, once we create an interface called friend, what do? You implement the friend in human and you implement the friend in dog. Well, sorry, that doesn't take you too far, because interface will not have the method. Well, you would have the method in the human in the class. Maybe you can make it a default method in Java 8. But before that, of course, we couldn't, so we create an abstract class separately. So that's going to require an interface and an abstract class. If that's the route you're going to take to implement it, why can't the compiler do that for you? That's exactly what the Scala compiler does for you. So I say friend over here as a trait, and what does the friend really have? The friend has two things: a val name, which is a string. This is simply a constraint to say anything that mixes this in is required to have this property called name, and it also contains the method listen into the class as well. So let's go ahead and just write that method right here within the friend. Now we can come into the human and say extends friend right here, and that becomes the trait that we are extending within the human. And I can then change this to a friend as well. We'll come back to the buddy in just a minute. We'll come back and see how that works. Now just let's run that through the human class. Well, human is a friend. Human doesn't have a listen method. That's in the trait. Now we come to the dog class, of course, and in the dog class we want to pass the dog class to the trait as well, but of course to the function as well, but we need to make the dog class also have this. So we say with friend, and this is how we can implement the trait right here to say that this is actually implementing this particular interface or the trait. Well, notice how that beautifully worked right here, where the dog is able to be a friend as much as a human is being a friend. Let's take this idea just a little bit further. Let's say we have a class called cat, which overrides val name, which is going to be a string as well. So in this case, the class cat extends from animal and a name as well. Now what am I going to do? Now I create an object alf is equal to new cat, and I have a new cat object sitting right here. Now I say seek help from alf, and would this work? The answer is no, it will not work. Why not? Because cats are not friends. Well, cat will kind of look at you and say, why are you here? Why don't you go back to work, isn't it? Well, you don't own a cat. You know this very well. The cat owns you. So, and I know what you're thinking. The person on the front row is like, that's not fair. I love my cat and it's friendly to me. I know some people have that illusion, that's okay. But if you do have that kind of illusion, so maybe your favorite cat, and you are so really saying, this is really my cat, and it's really favorite, it's a friend to me. So maybe that's really true, we'll try it. So here we go, your favorite cat, let's try it. Sorry, it didn't work. So the point really is, it doesn't really do it. But you're like, no, I really mean it. It actually kind of smiles at me when I go home. Well, cats are not friends, let's be honest about it, but maybe your cat is a friend. So you can actually make this an instance, if you will. So this is your cat, and whatever that cat name is, and you can say your cat is a friend. While cats are not really friendly, some cats are special. And so you can make this at the object level as well, and that is one really unique capability you see with trait. Now, obvious question is, if Java 8 has interfaces with default methods, then why would we care about traits, really? Should we just say default methods are good? Well, unfortunately, Java 8 default methods do not provide the ability of stackability. That is one of the most important features of traits, is you can bring multiple objects that implement the same trait, and they will stack up nicely, forming a train of objects rather than being isolated. So even though Java 8 solves the problem of traits a little bit, it doesn't entirely solve it. Default methods are not equivalent to traits because traits are a lot more powerful than default methods itself. So it's very well worth looking at traits in general. Moving a little forward, let's talk about one other thing we want to probably do in here. So in this example, let's take a little example of, let's say, a list of string, and we will go ahead and say, in this case, names is equal to arrays.asList. Let's create a bunch of names right here. So given these names values, what I want to do here is, let's try to give a bunch of names object here. So I got a bunch of names created. So here's what I want to do. Print comma separated the names in uppercase. Let's say but of length, let's say length is 5. So how do we print names of length 5 in uppercase comma separated? Well, we could start out with for string name coming from names and pause and say, that's really nice. I don't have to deal with the stupid I equal to 0. This is definitely nice, isn't it? Then I'm going to say output right here, name.to uppercase. But we don't want to print all the names. I only want to print name that is of length 5. So name.length is equal to a value of 5, and then go ahead and print it. Well, that printed Bruce and Darla, but you know that's not what we really meant. We want them on the same line. Sure, we can put that on the same line. But you want them comma separated, so you say plus comma. And then when you run it, while it worked, do you see that stupid comma in the very end? Anyone who has seen this problem before? Right? Every one of us. And the first time you saw that, you said, this is not happening to me, right? Because how do you really solve this problem? You sit there and scratch your head for a few minutes and you say, how do I do this? And then you come up with this brilliant idea. You said, I know I can do this. It's not that hard. All I have to do is int I equal to 0. How do you feel about it, right? And this is when all hope is lost. And you write this code and you say, there's got to be a better way. I mean, humans could not have been doing programming for a long time and not have figured this out, right? And then you realize that in the imperative style, there's no real good way to do it. This only gets worse because you say name.size over here, and then you ask the question, is it less than or equal to, not sure about it, I++, and then what do? Then you come in here and say, if I is not equal to, and then the names dot, you're like, no, this is not happening to me again. Well, the point really is, that is so bizarre. Why should it be so hard? Well, the point really is it doesn't have to be. What we can do is we can simply say names.stream, and then we can say filter, given a name dot length is equal to 5, And then I want to perform a map operation, string to uppercase. And once we convert to uppercase, what we want to really do at this point is simply say collect. And in this case, we're going to perform a collect operation. And collectors is a beautiful little utility class. Okay, it's not really that little, but it's a beautiful utility class that contains phenomenal methods. And what we can do is we can say joining, and then we can simply put a comma right there and be done with it. So this really eliminates a lot of effort we have to put in, and we can just get the work done and walk away. So we are saying, go ahead and take the collection, filter out everything but names that start with our length 5, then transform to uppercase, and then collect them, but while you're collecting them into a string, join them using a comma, and that makes the life a lot easier. It becomes really intuitive and easier to write. You don't have to endure the complexity that the imperative style code posed on us, which is an accidental complexity. Why bother wasting the time and effort doing it? So that is the joining method that makes life really, really easy. Let's move a little forward now. Let's talk about yet another feature that's really amazing, that can be really powerful. Let's define a method called compute for a minute. Where this compute method is taking, it's going to print out called right here, and then I'm going to simply say return n times 2. Okay, so it's just returning a n times 2 right now. Now I'm going to say val x equal to 4. Now I'm going to say if x is greater than 4 and the compute of 7 is greater than 3, then I will print out path 1. Otherwise, I'll print out, let's say over here, print out path 2. Well, as you can see here, I'm going to check x is greater than 4. It is not. X is greater than 5 to make it absolutely clear. And compute 7. My question to you is, will compute be called now? What do you think? No, right? Why is that? We know that feature as short-circuiting. Well, guess what? Short-circuiting was a concept introduced by John McCarthy way back in time in Lisp. And every language that any human has ever used has honored short-circuiting for most part, and we all rely upon it. We know this is true. So when I run the code this time, notice it said path 2. It never called the compute method. On the other hand, I'm going to take this as temp is equal to, and I'm going to say val temp is equal to compute. Question for you, will compute be called now? What do you think? Yeah, I see people sadly nodding their head. Should compute be called now? The answer is no. But you know one thing though, when you disagree with the language, you know who wins, unfortunately, right? So the language always wins. So in this case, of course, Scala decided to call the method, but you are like, no, you shouldn't be calling the method. And Scala says, but how would I know? What if the method has a side effect? You say, Scala, what if we can have an agreement within each other? I just wink at you and you don't call that method. Well, sure, Scala says that's called lazy. So notice here, I just marked it as lazy. And now that I marked as lazy, it's not going to call it. Just to prove the point right here, if we say over here, and I'll simply say, and now, and let's go ahead and say, print out temp right here. But notice how it defers calling the method until the very end. So it waits until the variable is actually used and doesn't really, call the method unnecessarily. So this can be really good in performance. If a method is going to be expensive to call, why bother calling it unless you really need the result for it? Well, that is Scala with the lazy facility available. I'm going to literally take the code, copy here into Kotlin. I'm going to say fun right here into Kotlin. It is fun because it's so much fun to write functions in Kotlin. And then I'm going to write this as a compute method. I say return right here. And this, of course, is returning n times 2 in the method. I have a val right here, as you can see. I'm going to go ahead and run this code here in Kotlin. I made only 2 little changes right here in this method, as you can see. That's all we did. And now when I run this code, you can see it called the method right there. But you're telling Kotlin, not fair. I don't want you to call this method because I'm not going to use it maybe. Well, you can do that by saying by lazy, And you can then ask Kotlin to treat it as a lazy as well, and that is lazy within Kotlin, as you can see. So it behaves very much like the code in Scala behaved, so you can use this delegate for laziness in Kotlin as well. That's nicely baked into the language, as you can see. So that is Kotlin code right there, which looks almost like Scala code for that particular purpose, but with a few differences that we just saw right in here. But given that, let's continue a little further. This is one of my favorite features in languages like Scala and Kotlin, which is the beautiful pattern matching capability. Can we talk about pattern matching for a minute? So let's say we call a method called process, and I'm going to pass a 1 to it, called process and send 15 to it, called process and send hello to it, and called process and send 1.5 to it. Let's take the process method. So a fun process, and I'm going to say input is of type any because I'm sending all kinds of objects to this. All I'm going to do is simply print out input just for a minute right here, and you can see that it printed all those values. But I want to take different actions for different values. By the way, here's the beauty. What I'm going to show you here will eventually be part of Java because Java is implementing pattern matching very similar to this. So languages are greatly influencing each other. Just like how Kotlin has been influenced by other languages, Java is being influenced by it too. So when over here input, and I'm going to say in this case, else, I don't have a clue what I'm getting, so I'll simply say no clue right here. So notice that for all the values, it simply says no clue for every single one of them. However, I'm going to say if it is 1, I'm going to simply print out you got 1. So notice in this case, it said you got 1 and then no clue for all the other things. But here comes the charm. I can say in 13 to 18 or 19 rather, and then I can say, let's say it's a teen. So you can even ask for a range of values. Isn't that really cute? So you can actually look for a range of values as well. Similarly, you can say is string, and then you can print out, in this case, it is a string. So if you notice over here, it tells you that it's a string, so you're able to get that value nicely through pattern matching, so that becomes a nice fluent way. All that ugly multiple if, else, and if code we ever wrote, they can go away, and we can write the code really nicely and concisely, as you can see here in the case of Kotlin. Again, Scala has very similar approach to doing pattern matching as well, and this is becoming very prevalent in languages, so we can reduce the boilerplated code and the ceremony and the verbosity in the code as well. So that is an example of how we can actually use that. But having said that, there's yet another feature in Kotlin, and there's also available in Groovy, that becomes really, really nice. But to illustrate the point, let's take a look at an example really quickly here. If I were to call a method called process, this is Java obviously, and I'm going to say hello right here, but I'm also going to call process with a 1, let's say. So what do you do to write the process method? You would probably write something like this. You would say void, and then you would say process, and then you would say input. This is going to be a object input. And then what are you going to do? You can output the input given to you right here within Java. But I really want to print out the length of the string. So I can say if input is an instance of, and then I'm going to say string, then what do I want to do? I'm going to simply output the string is of length, and then what am I going to say here? Length, and then I'm going to say over here plus input dot length. Will this work? No, it will not work. You know that already. What is missing here? I need to say string right here and do this and then call this length on it, right? So if I do this code, then it worked. Does anyone know what this feature is called? No? You said casting. No, it's called punishment. That's what it is, right? So that's what they do. They punish us, and you're like, why am I doing this? And I always ask this question that I'm really puzzled with. Do I work for the compiler, or does the compiler work for me, right? So I have this doubt. Do I work for the compiler or does the compiler work for me? I want the compiler to work for me because I want to get my work done. I don't want to sit there and do stuff and say, are you happy now? And the compiler is like, I want more. I don't want to do that, right? So in this case, notice I can just come to this code and I can simply say input.length, and notice how beautifully, in this case, it prints out. Well, in this case, of course, it's an input. And I'm going to simply say input.length. It's a length I'm going to call on this object. So notice in this case how beautifully it says it is a string of length. We'll say of length. And then, of course, it says it's a string of length 5. And it prints that out right there. Make no mistake, you are within the E string. So the code in here, you clearly know if you get to this path, it's a string. Just to be clear about it, if I go up here and print the input right here, notice it printed the input at the top right there, whatever we sent. But if I call the length right here, that's a compilation error because a length is not valid on any, but a length is valid on a string. And you can see that actually works really well. So that is an example of how you can beautifully enjoy this kind of auto-casting. Good news, Java is going to do this as well. Eventually, when Java implements these kinds of features, you will see this as well. Let's go to the next one we want to talk about. Let's talk about creating an XML document. Well, we're going to do this in Groovy because Groovy has a beautiful syntax for this. So let's go ahead and say we have a bunch of languages in here. So what do I want to do? I want to create an XML document with these language names and authors. Anyone here who is excited about writing code that writes XML? Not a single person raises the hand. Well, the first day you did it, you probably said, this is awesome. And then you realize that the job of writing code to write XML should be given to people in the prison. Nobody in the free world should be forced to do that, right? Well, the point really is that's not really very pleasant work to do. So let's see what we can do. We're going to create a builder. And the builder I'm going to create is groovy.xml.markup builder. And Kotlin also has very similar ideas as well. So if you're interested in doing this, you can do this in one of a few different languages as well. So what am I going to do here? I say builder.languages right now. Here comes the charm. Notice I just threw at it something called languages. Rather than complaining I don't understand it, the builder being a XML markup builder says, oh, you probably meant a root element, and notice how it beautifully popped out that little cute XML baby right there. So that is a little XML languages right there. Now I can go one level deeper right here, and I can say langs.each, and in this case I can say key, comma, value, and then within this, all I'm going to do simply is to say language right here. And notice in this particular case, when I create this language, it is going to create all these child elements for this language very easily. Then what I can do here is I can simply say that the name I want to provide for this is the key. And notice how they turned into attributes for these very nicely. And then finally, of course, I can come back here and say author, and then say the value that I want to use for this. And you can see how that became the child elements for that XML document as well, elements as well. And that's a really elegant way to produce XML output. So if you really want to be able to creating XML, Groovy doesn't make you feel all that bad to do it, so that becomes really easy to work with it. These kinds of builders, you may say, gosh, I don't want to really create XML, I want to create HTML. Sure, absolutely. Like I said, you can do this in Groovy, you can do this in Kotlin as well. You can pretty much create these things with a lot fluent syntax like this to create these kinds of things without having to put a lot of effort. Beautiful, this is really a DSL for creating these kinds of values. And that's exactly what you want to do to look in Kotlin. Look for DSL to create HTML, and you will find it. Well, let's continue a little further. What I'm going to show you next, you can do this in Scala, but you can do this in Clojure. They all do this differently, and here's what you can do in Kotlin as well. Let's take a little quick example right here. Let's define a function called factorial, where the function takes an integer as an input, but a big integer as an output. So in this case, I'm going to just import, let's say, java.math.star for now. And this is going to be, what is it going to return? I'm going to simply return a 1 for just a minute. So let's go ahead and print this out. We'll go ahead and print it factorial of 1, which is going to be a value of 1 after all. That's what we want to receive at this point. Well, in this case, of course, I'm going to simply say this is going to be a big integer of 1. So let's go ahead and provide the big integer of 1 and return that value for this to be printing it out. Well, okay, so n is never used. Ignore that for a minute. We'll come back to that. But what am I going to do in this case? Well, all I'm going to do now is to say equal to if n is equal to 1, return a big integer of 1. Otherwise, return n times factorial of n minus 1. So this is simply saying, I want to take this n and subtract big integer of 1 from it. So I'm asking it to return that particular value. So how does this really work at this point? Let's fix this error. So none of the following functions are called with the arguments applied, it's saying. Well, I'm passing this value 1 at this point. Well, this is going to be a number, isn't it? So I'm jumping a little ahead here. So that's going to be n minus 1. After all, that's what I want to pass to it. Okay, so this is going to say return a big integer of 1. If it is a value of 1, if it does not take a n times a factorial of n minus 1, and that's what we want to return. But this is going to be a value which is a big integer, so we'll say a big integer of n.toString and get the string out of it so that we can call this a little working around that. Okay, let's try this for a value of 5 really quickly. And when I do this for a 5, what happens? Notice that it gave you 120. Maybe you're having a party and you are this big fan of recursive calls and you are saying how awesome recursion is. And there's always this one person in the party who's very skeptic, right? And they say, you think recursion is cool, huh? And you say, absolutely, look at this, how beautiful this is. I can even do this 500. And notice how beautifully that produced the result. And this person who doesn't like recursion tells you, oh yeah, try this now. And what's going to happen when you try that? Unfortunately, the party is over. Everybody leaves, right? Because you got a Stack Overflow error, and that's no fun. So what do we do about it? Well, the problem here in this example is we are using recursion, and recursion is adding stack layers to us, and that becomes really painful over time for us to work with. So wouldn't it be nice if there can be optimization to remove that stack and be able to really stay at one level? Well, this is where some really powerful things can come in. So I can say tail rec right here. So we color that, we taint it with a little decorator, which is a tail rec. Now what am I going to do? Well, with this being marked as a tail rec, I'm going to go here and say comma over here. Fact is going to be a big integer, but the big integer is going to be the value big integer of 1. I'm using beautifully here a default argument in Kotlin. So Kotlin provides ability to do default arguments, and I'm saying if the value is not given to me, then please use a value of 1. And then what am I going to do? If n is equal to 1, then return the factorial, the fact. Otherwise, go ahead and return for me the call to factorial, but the first argument is going to be n minus 1, and the second argument is going to be factorial times a big integer of n.toString. So I take the n and multiply with the factorial and pass it and call with n minus 1. So what is going to happen with this piece of code? When I run this, notice it said 120, but now you can invite everybody to the party, including that loser who doesn't like the recursion, and you can show how beautifully we can actually start optimizing things. So you can see in this particular case, and don't try to memorize that one, but that's the result of using the factorial for a high number. So the optimization is done by the tail rec. Two things about tail rec. You got to mark it as tail rec, and if you don't, it falls back into a regular recursion. And secondly, when you do mark it as a tail rec, if the call is not in the tail position, you will get an error. So this has to be in the tail position. Otherwise, this will give you an error as well to say you can't really use this particular feature. So that's pretty much done by this as well. Well, this takes us to the last two things I want to talk about, both in Kotlin, and one of them is extension methods. Now, to be able to add domain-specific methods is really cool. I started out by saying earlier, to be able to add a method like execute is really nice. So I worked on a project where we had to provide a lot of domain-specific methods for an insurance business. Oftentimes we had to ask the question, does the insurance, is the insurance valid on a particular date? Wouldn't it be nice to say date.isValid and pass an insurance object to it? Well, you can do all of that very nicely thanks to extension methods. So what can you do with extension method? Let's take a look at an example of this here in Kotlin. So what I want to do here is take a string hello, and let's say H is uppercase and everything else is lowercase, and then I'm going to say hello dot, let's say shout, and I'm going to call a method called shout on hello. Well, before that, let's just print the hello alone for a second, just to be sure. And in this case, of course, it printed the word hello, but I'm going to call a shout method on hello. We know that there is no shout method on hello, but you don't have to take no for an answer. You simply go up here and say fun, string.shout is equal to, and implement your own implementation. In this case, all I'm going to do is simply call to uppercase right here. So when I run this code, notice how it actually prints that in uppercase. We just added for ourselves a method called shout onto the class called string. Make no mistake, this is not modifying the class, but instead the compiler will, the minute it finds the shout method, will replace that with a call to this method. That's what it's actually doing. So in this case, let's go back to hello, but we'll call to lowercase right here. And in this case, of course, it's going to print the hello all in lowercase. Well, that worked actually. But I was giving this presentation once, and there was a developer in the talk, and he got overly excited, and he said, wait a minute, can I do this, he asked. And he wanted to override existing methods, like to lowercase. Now, the question really is, can we do it? And remember, we all live in free countries these days. It's your code. You can do whatever you want to do. So if you want to really do this, go for it, and you are able to change what lowercase does. What really bothered me is not the fact that you could do it, it's the fact how excited this developer was upon seeing it. I can see pure evil in his eyes after this. Not very fun thing to do. So just because you can do doesn't mean you should do it, so don't do that. So the point really is you're not only able to add new methods, but you're also able to replace methods in your code as well. That is something you have to use very carefully, of course. To wrap what we are talking about, I want to show you one more thing, which is fluency within Kotlin. Now, to understand what this means, let's create a class called car for a minute. The car contains a turn method, which takes a direction right here called a string. And all I'm going to do here is print out, let's say, turning, and then we will simply say direction. So this is going to say turning direction when we call this. Let's create a car equal to car, a new car object. Then I'm going to say over here a car.turn, and I'm going to say in this case left, and then I'm going to say car.turn, and I'm going to say right over here. Now, as you can see, this code is a pretty boring code we have written. We know this, we have done this for a long time in a lot of different languages, so it is nothing really new for us because we have done this quite a number of times. But having said this though, in this case, I'm going to simply return this as well at the very end of this call to say, I want to return that particular object. Well, if you notice over here, this object, I want to just return this from this call. Let's say return is not allowed here. Let's see why it doesn't like it. So this is going to be returning a car object. That's what I want to return from this particular call. Let's fix this real quick. So this is going to be a method that's returning the car object. Well, notice the ceremony of the semicolon. Nobody gets really excited putting semicolons. If you want to write fluent code, you may not want semicolon. Well, that's the very first thing. Like languages like Scala and Groovy, Kotlin doesn't require you to use semicolon as well. And notice that I was able to remove it. Well, you know one thing though, you could have done this though, you could have written it like this. So that's a little bit of a simplification, but all that dot is still noisy, isn't it? Well, if I remove this dot from here and remove the dot from here, and notice how you are able to call this without the dot. It doesn't work. But what you can do is you can just tell Kotlin, come on, we are friends, can't we just make this happen? So you can say infix on it, and by marking it as infix, you can then start writing code without having to use the dot. This can be a really powerful way to create DSLs or fluent syntax, which is usually what you do when you create DSLs. So this becomes a really nice way for us to create interfaces where we can be a little bit more fluent, and that's an example of how you are able to mark a method as infix, and then once you mark it as infix, you don't have to provide the dot to really call it, and you can make it a little bit more fluent, as you can see. So what we did here is we talked about a dozen ways to do cool things in Java 8, Groovy, Scala, and Kotlin. One of the beautiful things about this is, if I find there is a better way to do in another language, and the fact that these languages can run on the JVM, I can reach over and make use of them. And so it really puts it gives me the power as a programmer to choose what I want to use rather than being forced down a path. And I think that's such power to us, the programmers, really makes us more productive. And that's one of the reasons I really get excited about languages in general, is because what I can do with them, and also coming back and seeing what I can do with the languages I already use. And that's one of the biggest benefits. If you want to download the example I showed you here, feel free to go to this URL, click on the downloads link, and you should be able to download the code I just showed you. I hope that was useful. Thank you.